In this video, we are going to go over naming alcohols, or naming compounds with alcohol functional groups. So the first thing you do is identify the longest continuous chain or ring, the parent chain, that contains the hydroxyl group. You assign the parent name using the Latin prefixes, and replace the E at the end of the name with ol. So we have ols for alcohols. Then number the parent chain starting from the end closest to the hydroxyl group. For rings, begin numbering at the carbon atom with the bond to the OH. Place a locator number followed by a hyphen before the parent name to indicate which carbon has the bond to the hydroxyl group. Cycloalkanols are not assigned a locator number unless there's other substituents on the ring. So for example, we have this structure. The parent chain has 6 carbons. 1, 2, 3, 4, 5, 6. The hexane becomes hexanol because it is an alcohol. The right end is closer to the alcohol, so it's numbered from right to left. And then the locator number for the carbon that is attached to the alcohol is 2. So you have 2-hexanol. If we were to number from left to right, it'd be 1, 2, 3, 4, 5, 6. And our carbon atom that's attached to the hydroxyl group would be 5, and that's too high. That's a lot higher of a number than 2, so that's why we number it from right to left. So naming branch chain alcohols. You apply the rules for branch chain alkanes using the numbering rules for the parent chain of alcohols. So we have the same rules applied here. We have 1, 2, 3, 4, 5, 6. This is hex, is 6. So hexanol because it has an alcohol group. We have our carbon number 2 is where the OH is. We want our locator number for our hydroxyl group to be the lowest possible, and that will supersede the substituent. So if the substituent was at carbon 2, numbering from 1 on the left-hand side to the right, we would still want to number right to left because we want our hydroxyl group on the lowest number. So we see we have a 2-hexanol. Our hydroxyl group is on 2. And then we have a methyl group right here on carbon 4. So it's a 4-methyl 2-hexanol. So it's the same branching, numbering rules and naming rules as alkanes, alkenes, and alkynes. So we're going to practice drawing these structures for the following alcohols. Go ahead and pause the video, and when you're ready, unpause and we'll go through it. Okay, so the first thing I'm going to do is write my zigzag conformation for this. Oct is 8. Ol means there's an OH. So I'm going to do my 8. This is 1, 2, 3, 4, 5, 6, 7, 8. The 3 tells me that the hydroxide or the hydroxyl group is on carbon 3. So I'm going to put my OH here. Cyclopentanol, pent is 5. So I'm going to do a pentagon, 5-carbon or 5-sided ring. There's no second substituent on here, so I can put the OH anywhere. So I'm just going to put OH. And this would be my carbon 1. 5,6-dimethyl-1-heptanol. So hept is 7. Ol means there's an OH. I'm going to go ahead and do my zigzag. So 1, 2, 3, 4, 5, 6, 7. My OH is on 1, carbon 1. So I'm going to write it like this. Notice that I didn't write OH. I wrote HO because this shows me that this carbon is bonded to the oxygen and the oxygen is bonded to the hydrogen. Okay, so make sure you draw it the correct way. Then we have two methyls on 5 and 6. So methyl on 5 and a methyl on 6. So in summary, the IUPAC naming for an alcohol is assigned based on the number of carbon atoms in the longest continuous chain or ring that contains the hydroxyl group. So if there is a longer chain that does not have a hydroxyl group in it, that is not going to be your parent chain. The hydroxyl group takes precedent over it, and that is going to, the chain with the hydroxyl group is going to be your parent chain. And then you change the ending to all. A locator number is added to identify the carbon bonded to the OH group. And then branched alcohols are named according to previous rules.